Hey class, today we're going to be looking at the distance formula, and this is just an extension and a little bit of a simplification of what you've been working on the past couple weeks when you've used the Pythagorean theorem to find the distance between 2 points. So our learning target for the week is I can find the distance between 2 points using the distance formula. So in the past, we were looking on the coordinate plane, we were able to count the squares, but this time we're going to extend it so we have just one formula that we can plug our 2 points into. So let's take a look. So as I said before, the origins of the distance formula is in the Pythagorean theorem. So if we're trying to find the distance between 2 points, x1, y1, and x2, y2, we can draw in the legs onto our coordinate plane. This is what we did in the past couple weeks. And remember, the legs are the two sides on either side of the right angle. Okay? And then in the past, we would count to see how many squares are here on our horizontal side for A. Another way we can do this is do x2 minus x1. Okay, and then we need to figure out how tall the triangle is. So we count our B, or we can just do y2 minus y1, and that's this distance here. Okay, then we're going to plug it in. So if you come over here to the left side, we're going to plug it into our Pythagorean theorem. So we have x2 minus x1 squared plus y2 minus y1 squared equals c squared. And then in order to get rid of that weird little square up there, we're going to take the square root of both sides, which means that c, or the distance between these 2 points, is equal to the square root of x squared, or x2 minus x1 squared plus y2 minus y1 squared. Okay, so just go to the next slide. See here, it has just the distance formula. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and you can see that from the picture here as well. So now let's look at an example of using this distance formula to find the distance between 2 points. So we have the distance between the points -1, 3 and 4, -7. So we're going to use our distance formula and plug in our points x1, y1, and x2, y2. As you can see, I label them. It just helps me keep track of everything. Okay, so we have x2, which is 4, minus x1, which is -1, plus y2, which is -7, minus 3, which is y1 there. Okay, and then 2 negatives make a positive. So we have 4 plus 1 and -7 plus -3, because if they have the same signs, you add and keep the sign. Okay, and then we simplify it. So we have the square root of 5 squared plus 10 squared, and 5 squared is 25, 10 squared is 100. So we have square root of 125, which simplifies down to 11.18 units. So that's the distance between these 2 points. If we were to graph it on the coordinate plane, you would find that the distance is 11.18 units. And of course, that's an irrational number, so that's just an approximation. Okay, so that's it for our example. If you have any questions, please come to office hours, send me an email, text a friend, whatever you need, but just know that we're all here for you to help. There's also quizzes link here in the slideshow, and then your assignment. Okay, thank you guys. Have a wonderful day. I have to figure out how to stop recording.